In this video, we will take a look at Ohm's law, how it was discovered, and Ohm himself. George Simon Ohm was a German physicist born in 1789. He attended the University of Erlangen, where he received a doctorate in 1811. He then went on to lecture physics and mathematics at the Gymnasium of Cologne, where he was also able to perform experiments which led to him publishing his first book in 1827, containing his complete theory of electricity, including what is now known as Ohm's law. Ohm's law relates the current flow, resistance, and voltage of an electrical circuit, noting that voltage is proportional to the current and the resistance as seen in the equation V equals IR. Let's take a look at some examples. Here we have a simple circuit consisting of a battery and a single resistor. We know that the resistor has a resistance of 5 ohms and that there is 2 amps of current flowing through the circuit. We want to find the voltage applied to the circuit to make this true, so we need to simply sub in our values of resistance and current and multiply them to give 10 volts. This circuit is very similar to the last one, but in this case we are given the voltage and the resistance and need to calculate the current flowing through the circuit. For this we need to rearrange the equation V equals IR to solve for the current, giving I equals V over R. From here we just divide the applied voltage by the resistance to find that there is 2.4 milliamps flowing through the circuit. Ohm's law can be extremely helpful in calculating the current through or resistance of a parallel branch in a network without needing to calculate the current through all branches. In this case, we have a parallel circuit with 3 branches. The voltage applied by the power supply is 10 volts and the resistance of branch 2 is 5 ohms. Knowing that the voltage over all branches is 10 volts because they all feed from the same node, we can divide the voltage by the resistance R2 to find the current through branch 2 to be 2 amps. If we did want to calculate the total current through this circuit, a simpler and faster approach is to find the total resistance of the circuit by adding the inverse of the resistance of each branch and taking the inverse of that to get the total resistance as shown in the working. This results in a total resistance of 2.61 ohms. Then we can use Ohm's law to calculate the total current, which is 3.83 amps. Ohm's law can be applied in AC circuits as well. By dividing the voltage by the current, we are able to determine the resistance of this AC circuit to be 2 ohms. A graph of the voltage and current waveforms can be seen to the right of the circuit diagram.